Hello friends, welcome to lecture series on essential mathematics for machine learning. Now in this lecture we will see some continuous probability distribution functions. So like we will see normal distribution function, we will see uniform distribution function and what are their various properties and how can we solve few problems based on this. So the first one is uniform distribution function. So what is a uniform distribution function? A random variable x has a uniform distribution and it is referred to be as a continuous uniform random variable denoted by x u close bracket a to b. Its probability density is given by 1 upon b minus a when x is between a to b and 0 otherwise. Okay. So, this is simply a notation of this u a b is simply a notation for uniform distribution in an interval a b, and it is how it is defined. It is defined as this, it is 1 upon b minus a when x is between a to b and 0 otherwise. So, these a and b are two parameters of this continuous distribution function. So, how you can find its mean or variance? The mean of this distribution is given by a plus b by 2 and variance is given by 1 upon 12 b minus a whole square. So, how we can obtain this? So, let us see. So, first of all, how we can define uniform distribution? As we have seen, it is simply okay, we can write the full notation u x a b which is equal to 1 upon b minus a when x is between a to b and 0 otherwise elsewhere. So, first of all, if you want to see that it is a distribution function. So, integral minus infinity to plus infinity u of this x a b dx should be equal to 1, of course. So, let us verify it quickly. See, minus infinity to plus infinity of this for this one, see it is what u x a b, okay, which is further equal to, from a to b it is 1 upon b minus a, from a to b it is 1 upon b minus a 0 otherwise. So, it is this which is further equal to 1 upon b minus a integral of dx is x a to b which is equal to 1. So, quickly we can see that it is a distribution function. Now, if we want to find out its mean or variance, so how we can proceed? So, for mean or expectation of x, we know that, so expectation of x for uniform distribution is given by minus infinity to plus infinity x into u x a b dx, which is equal to a to b x into 1 upon b minus a into dx, because it is 0 otherwise. So, it is further equal to 1 upon b minus a will come out, it is integral a to b x dx and its integral is what? It is further equal to 1 upon b minus a, it is x square upon 2 a to b, it is further equal to 1 upon 2 times b minus a into b square minus a square, which is equal to a plus b by 2. So, this is how we can find out mean of this distribution function. Now, how can you find out its variance? So, we know that variance of distribution is equal to expectation of x square minus expectation of x whole square. So, what is expectation of x square for this distribution? It is equal to minus infinity to plus infinity x square into u of x a b, which is equal to integral a to b x square into 1 upon b minus a dx, which is further equal to 1 upon b minus a, and this is x cube upon 3 a to b, which is equal to 1 upon 3 times b minus a into b cube minus a cube. So, this is equal to b square plus ab upon 3. Now, what is variance? Variance of x will be b square plus a square plus ab upon 3 minus what is expectation of x, that we have already computed. Expectation of x is a plus b by 2. So, it is minus a plus b by 2 whole square. This is equal to, it is 4 times b square plus a square plus ab minus 3 times a square plus b square plus 2 ab upon 12, and this is equal to what? This is equal to a square plus b square, this is minus 6 ab plus 4 ab is minus 2 ab upon 12. So, which is equal to a minus b whole square divided by 12. Okay. So, which is here b minus a whole square upon 12 is the variance and the mean is a plus b by 2. So, this is how we can compute mean or variance of a uniform distribution function. Now, let us see these simple problems based on uniform distribution. Now, suppose x is a uniform distribution, follows uniform distribution which is given by minus a2 plus a interval, a is greater than 0. Then determine a so that probability of x less than minus half is 3 by 10. So, this we have to compute. So, let us see how we can compute a for this problem. So, we have to compute it is given to us the probability of x less than minus half is 3 by 10. Now, what is this distribution? For this distribution minus a2 plus a, this will be what? This will be 1 by b minus a, that is 2 a when a minus a less than x greater than a and 0 otherwise. Okay. So, that means from minus a to minus half, because see we have to find out the probability when x is less than minus half. So, that means the integral from minus a, because it starts from minus a to minus half, this integral of 1 upon 2 into dx is 3 by 10. Okay. So, this implies 1 upon 2 a minus half plus a is equal to 3 by 10, which further implies minus 1 by 4 a plus 1 by 2 is equal to 3 by 10. This further implies minus 1 by 4 a is equal to 3 by 10 minus 1 by 2 is equal to, you can take 10 LCM, it is 3 minus 5, that is minus 2 by 10, and this implies that 8 a is equal to 10 or a equal to 10 by 8 or 5 by 4. So, this is the value of a for which probability of x less than minus half for this problem is 3 by 10. Now, the second problem is, if it is given to us that x follows uniform distribution of in this interval minus 2 to 3, then we have to compute probability for x greater than 1. So, what is given to you here, that x follows uniform distribution function from minus 2 to 3 and you have to compute probability for x greater than 1. So, this will be equal to 1 to 3, it is 1 upon b minus a, b minus here is 5, 1 upon 5 into dx, because it is b minus a, it is a, it is b. So, it is what, 1 upon 5 times x 1 to 3, which is 1 upon 5, 3 minus 1, that is 2 upon 5 or 0.4. So, the probability for x greater than 1 is 0.4 for this problem. So, these are very simple illustrations meant for uniform distribution functions. Now, next is exponential distribution. So, how we define exponential distribution? It is also a continuous distribution function and its probability density is given by 1 upon lambda e raised to power minus x by lambda when x is greater than 0 and 0 otherwise. This lambda is a parameter which is always greater than 0 and the mean and variance of this distribution is given by lambda and lambda square respectively. So, let us quickly see, first of all we will check that it is a distribution function and then we will compute its mean and variance in the similar way as we did for uniform distribution. So, what is the PDF of this distribution? So, PDF is given by, it is an exponential distribution and it is given by exp of x lambda, which is equal to 1 upon lambda times e raised to minus x by lambda when x is greater than 0 and 0 otherwise. Okay. So, 0 otherwise means here it is for positive values x less than equal to 0. So, first we will check that from 0 to infinity this distribution is 1. So, this implies it is 0 to infinity 1 by lambda e raised to power minus x upon lambda dx, which is equal to 1 by lambda e raised to power minus x upon lambda, okay, 0 to infinity, and it is upon minus 1 upon lambda. Okay, we are integrating it. So, this is minus of, now when x tends to infinity this tends to 0 and at 0 it is 1. So, it is 1 minus 1. So, it is 1. Okay. So, this is the first check. Now, second we will find the expectation of x, it will be 0 to infinity x into 1 upon lambda e raised to minus x upon lambda dx, which is equal to what, 1 upon lambda times integral 0 to infinity x into e raised to minus x upon lambda dx. This is further equal to 1 upon lambda, you can integrate it. So, it is first as it is integral second minus derivative of first integral of second 0 to infinity. Now, when x tends to infinity this value tends to 0, we can show it also. See limit x tends to infinity x upon e raised to power x upon lambda will tends to 0. This is very easy to show. Okay. Either you apply L'Hospital rule or you can expand this series of e raised to power x. At 0 it is also 0 because it is x here. At infinity now this is what? This is minus of lambda times at infinity it is 0 and at 0 it is 1. So, it is lambda. So, expectation of x will be lambda. Okay. And how we can compute variance? So, see, for variance we have to first compute variance of x will be what, expectation of x square minus expectation of x whole square, and expectation of x square is what, integral x square into 1 upon lambda e raised to a minus x upon lambda dx from 0 to infinity, and this is what, this is x square by lambda. Okay. This is 1 upon lambda integral 0 to infinity x square e raised to power minus x upon lambda dx. See, for this distribution it should be from minus into plus infinity, but since for x less than equal to 0 it is 0. So, I am not considering negative real side, negative side, because it is 0 here when x is less than equal to 0. So, if you take here it is minus infinity. So, because for negative side it is 0. So, I am not taking it into picture. Okay. Now, you can integrate over here, it is 1 upon lambda times, you can take it first as it is integral of second minus 2x e raised to minus x upon lambda into 1 by lambda whole square plus 2 into e raised to minus x upon lambda upon 1 by lambda whole cube with minus sign 0 to infinity. Okay. Now, at infinity it is 0, at 0 it is 0, again at infinity it is 0, at 0 it is 0, only this term left, and this is further equal to minus 2 lambda square 0 minus 1, which is 2 lambda square. So, variance of x will be 2 lambda square minus lambda square, which is lambda square. So, this is how we can find mean and variance of exponential distribution function. So, where exponential distribution function used? So, example of event that may be modeled by exponential distribution include the time until a radioactive particle decays, the time it takes before your next phone call, the time until default in reduced form, credit risk modeling, etc. Okay. So, now we have one problem based on exponential distribution. It is given that the duration in minutes of a phone call follows the exponential distribution with lambda equal to 5, and we have to calculate the probability that a phone call exceeds 5 minutes. So, it is very simple problem. See here lambda is what for this problem? Lambda is 5, and we have to take probability for x greater than equal to 5. So, that means it is 5 to infinity, exceeds 5, fine. So, it will be 1 by 5 e raised to power minus x upon 5 dx, which is 1 upon 5 e raised to power minus x upon 5 upon minus 1 by 5 to infinity. So, 5 cancels out, it is e raised to power minus x upon 5 to infinity. At infinity it is 0, and at 5 it is e raised to power minus 1. So, that is 1 upon e. So, this is the required probability. Okay. So, this is how we can solve the problem based on uniform or exponential distribution functions. Now, let us come to Gaussian distribution, which is an important distribution in terms of machine learning. Okay. Because you must have an idea for discrete case also, that how we can find out mean, variance, etc. for discrete distribution, then only I can come to normal distribution or Gaussian distribution, which is an important aspect for machine learning. So, if we follow what is the distribution function for this? So, let us see. A continuous random variable x is said to follow a normal distribution denoted as n mu sigma square. Here mu is mean and sigma square is variance, if its PDF is given by this expression, where sigma is greater than 0 and x is between minus infinity plus infinity, and mu is of course from minus infinity plus infinity. So, its mean is mu and variance is sigma square. Basically here they are basically 2 parameters for this distribution, but they are not only the parameters. Here this mu is nothing but mean, and this sigma is nothing but standard deviation of this distribution. So, how can we say, how can we prove it? So, first for simplification, let us see here the distribution is given by 1 upon under root 1 upon 2 under root this sigma, okay, this e raised to power exponential raised to power minus 1 upon 2 x minus mu upon sigma whole square. Now, let us take a small transformation, let us take z, which is x minus mu upon sigma. Okay. Now, of course, if if this is mu and sigma square, okay, if this n is mu and sigma square basically, if this x is. So, in terms of z, what will be n? So, when this is mu, so this is 0, and when if you find the variance of this, so variance of z will be 1 by sigma square variance of x, and variance of x is sigma square. So, sigma square will cancel out, so it is 1. So, this is called standard normal variate. Basically, we have transformed this into 0 1. So, what will be fz? Fz will be 1 upon under root 2 pi e raised to power minus z square upon 2. So, because of this transformation, sigma will cancel out. So, now this is a very simple expression to see the Gaussian distribution, and which is a normal variate with mean 0, standard deviation 1. Now let us try to prove that its mean is 0 and standard deviation is 1. Of course, if mean of this is 0, then if this is 0, then mean of this for this distribution will be mu, and if its variance is 1, then variance of x will be sigma square, that we can simply obtain by using the property of variance or expectation of x. So, now the only thing we have to show that the mean of this distribution is 0 and the variance is 1. So, expectation of x we have to find, so or z we have to find basically expectation of z here, which is minus infinity plus infinity. This is z into f z d z. This will be minus infinity to plus infinity z 1 upon under root 2 pi e raised to power minus z square upon 2 dz. Okay. it is an odd function, and for odd function it is obviously 0. So, that is clearly one step answer you can obtain that it is 0. Okay. Now you have to compute for variance, you have to compute expectation of z square, that is integral this to this z square 1 upon under root 2 pi e raised to power minus z square upon 2 dz. And now it is an even function, for this it will be 2 times 1 upon under root 2 pi 0 to infinity, it is z square e raised to power minus z square upon 2 dz. Now you can take z as under root 2 times t, suppose. Okay. So, dz will be what? Under root 2, it is 1 by 2 t raised to power minus half into dt. So, that will be under root 2 upon pi integral 0 to infinity z square is 2 t e raised to power, now it is nothing but minus t, okay. And dz is what? Dz is 1 upon under root 2 t raised to power minus half into dt. So, this will cancel with this 2. So, finally, we are having here is equal to 1 upon under root pi, okay. 1 upon under root pi will come from here, 2 also will go out. So, that will be into 2 integral 0 to infinity, that will be t raised to power half e raised to power minus t finally. And this is nothing but gamma 3 by 2, okay. And that is further equal to 2 upon under root pi, and this is gamma 3 by 2 is 1 by 2 under root pi. So, this is 1. So, variance of x is what? Expectation of x square minus expectation of x whole square. So, that will be 1 minus 0, that is 1. I mean for z, this is z here. Okay. So, in this way we can say that for this random variable which is following normal distribution, for this mean is mu and variance is sigma square. Okay. So, now let us come to one problem based on this, simple problem based on this. The time required to assemble a piece of machinery is a random variable having a normal distribution with mean 12 minutes, that is mu equal to 12, and standard deviation is 2 minutes, that means variance is 4. So, what is given to us? It is given to us that mu is 12 and sigma is 2, okay, 2 minutes. This is also minutes. Okay. What is the probability that assembly of piece of machinery of this kind will take anywhere from 11 to 14 minutes? So, what we have to find? We have to find that probability of x when x is between 14 and 11. Okay. So, this is nothing but, so for standard normal variate z is x minus mu upon sigma, which is x minus mu is 12 upon sigma is 2. So, when you substitute x as 11, so it is minus 1 by 2 less than equal to z less than, when you put 14, so it is 1, and this is nothing but p when x is less than 1 minus p when it is z. So, it is z, so z less than 1 and this z less than minus half, which is given to us. It is given to us that this value is this and this value is this. So, this is simply difference of these two. So, you can find out a difference. So, it is 0.8413 minus it is 0.3805. So, this difference is 0.4608. This is the final answer for this. So, sometimes this is simply for illustration that if a problem of this type is given to you, that how you can convert that x into a standard normal variate, and then how you can find out the respective probability based on that. So, this distribution, which is the last distribution here, Gaussian distribution, or we sometimes call as RBF kernel also in terms of machine learning, So, in this lecture we have seen that if we are having discrete distributions or continuous distribution and we want to find out expectation or variance, and if you want to solve some simple problem based on that, then how we can do. Thank you.